So hi, my name is Lumendek. I prefer name as Kenny, and this is my student ID key card. Okay, let's get started to the presentation about my understanding for coding for the assignments. So let's start from the task one. So in the task one, I created a word class to represent each word in the lexicon, and every word from the input file is stored as a word object, which hold the words lowercase text, its currency count, and a list of neighbor, which will populate it in the later task. So I already set the default frequency of the word is 1 here, and if it appear again, and it will go to the function called increment frequency, and would be updated to count it again if it appear again in the text. And to support later features like neighbor detection and sorting, I added several key methods. Um, the the is neighbor here is method to check if another word have the same flag and differs by exactly only one character, and this is essential for task 5. And the eq function here is to let us detect the duplicated based on the text. And I also and the lt here is enable the alphabeting sorting, and I also add another functions called the rep_r to make the word object easier to inspect during the debugging. Now let's moving on to the task 2. So in task 2, I already implemented the logic for the loading word from the input, and I develop a method called read data here, and that accept all the files name and the lexicon as the input. But the file is open in this function, and each line is read. Each line is split into the individual raw words over here by this function, and then I clean each word by removing all the non-alphabetic characters using a list comprehension, and this strip out any punctuation, digits or symbols, and also convert the result to a lowercase to ensure the case identity. For much more easier, I want to make, for example, here is the word you and you. Both of these words are the same, so I want to treat it at the same way, not for the so I all change the word into the lowercase to much more easier to detect it. And finally, I also implement the tree calls to the read data here to load the contents of all the text in the file, and to ensure that the lexicon will contain every valid unique word from all three files along with the accurate frequency counts for each. Now moving on to the task 3. So first I turn the selection sort here method on that list to sort the lexicon. A list of the word object is sent into this method and to sort the lexicon. So the algorithm works by selecting the smallest element in the unsorted portion of the list and swapping it with the element at the current index. So especially for each index as the I over here, I assume that the word is I is the smallest, and then I look through the rest of the list from I plus 1 over here to the end to find any smaller word exists in the alphabetically. And if a smaller word is found, I updated the min index over here to swap again. So for the second sorting method, I use a hybrid merge instruction sort, which combine the ease of the use and a little overhead of instruction sort for tiny sub-arrays. And after that, I already established the threshold 10 here. The method shift into the instruction sort to reduce the expense of recursive subarray has a 10 or fewer entries. For task 4, I developed a main function method in task 4 using the read data method, which is written to tree file over here. So after that, through this method, a dictionary is filled with a lowercase word for the keys and word objects for the values, which hold the word frequency and the neighbor information. The next step I do is to convert all um, um, so the next step is to turn the lexicon values into a list over here. It's called lexicon list so that the sorting algorithm may be used in as dictionary or in really an order. And then after this, the program will prompt the users to choose between two options, the selection sort or the hybrid merge instruction sort by typing either one or two, and based on the input, the corresponding sorting function is executed. I can try over here. So after run, then I choose number one, and it will sort for me by using the selection sort. And for the optional, um, for the basic verifications, I also the script to screen to print out the 10 sorted top 10 word along with their frequency count over here, so that I can know that my code has running correctly. And moving to the task 5, first I implemented the add neighbor here function to populate the each word in the lexicon with a list of the valid neighbors. According to the definition, the two words are neighbor if they are on the same blend and just only differ by only one letters. So to check this, I create a is neighbor here to check and to compare the two string of the word, and then counting how many portion or position that are different, and if the count is exactly one, then the function return true. And so for the inside of the add neighbor, I look through every single one and compare it with another word. Mm, and if the two words are the neighbor, I added the matching word object into the temporary list. Once the list is complete, I sort it in alphabet and custom for another function called instruction sort word objects. Function as built in the sorting function are not allowed. So I assign this function to and this step to ensure that every word in the lexicon has appropriately sorted as the list of the neighbor words. So moving on to the last task is task 6 is to write a lexicon into a file. So in opening, I implement the right data over here to export the entire lexicon into a file word called out.txt, and this function is to ensure that all the words are written in a strict alphabetical order and along with their corresponding frequencies and a sorted list of neighboring words. So to enforce that, I first implemented I reused the custom selection sort function to sort the list of the word objects, and then the insertion sort here to do it again to make sure that all the words are in the correct order. And the final output strictly matches the example provided in the assignment. Each line shows the word and its frequency and a list of the neighbor inside square brackets with quotes. So, and to be sure, I already write another line here. Two line here is to make sure that when I running all the code, and it will have the file out.txt in my file, as you can see here. And this is my output.txt, and this is like nearly the same as the required for the assignment. So that's all. So after running all time again, so let's run all the code again. this tablet is to calculate the time. So as in the previous, I choose number one, now I choose number two here. And already sorted by the hybrid sort. Thank you. And thank you for listening for my presentation about the code. And this is my student ID card.